destacaria também o seu aspecto extremamente social, amigável, e, claro, a simpatia que ele nutre pelas terras brasileiras e
gravar o áudio também,
né, que nos permite
gravando seu áudio,
ser contemplados por sua presença, ainda que não na frequência que nós desejamos. Então, para a gente, eu acredito que, particularmente para mim, mas para todas as pessoas que tiveram a oportunidade de conhecer o professor Merran em suas estadias prévias pelo Brasil, creio que todos compartilham da minha opinião acerca da qualidade do seu trabalho, de sua facilidade de trato, de seu caráter amistoso, né, e de sua competência técnica. O professor Merran tem trabalhado essencialmente, tem focado os seus trabalhos em materiais não convencionais, um assunto que será objeto da sua próxima palestra, né, é a gestão, a recuperação de áreas degradadas por lixões, gestões de aterros sanitários, comportamento mecânico de resíduos urbanos, com aspectos de biodegradação associados, né, como que esses aspectos afetam o comportamento mecânico do material, dos resíduos, já que o resíduo é o material de construção dos aterros, materiais não convencionais, materiais de baixa densidade, né, para uma série de propósitos, dos quais ele certamente vai tratar na sua apresentação, né, e então eu acho que a sua apresentação fará melhor, né, e falará mais dos seus predicados do que a minha breve introdução a vocês aqui essa noite, tá bom? Então, Merran, I will pass the word for you, and I wish you a very good presentation. I am here to add in anything you want, and good luck. I think that everyone will enjoy your presentation, and that is it, okay? And, pessoal, a gente vai fazer o Merran vai fazer a apresentação em inglês, ele entende também um pouquinho, né, ele fala bem português, né, mas é óbvio que, estando fora do país, depois de um certo tempo, a gente perde um pouco o traquejo com a língua, e por isso a apresentação em inglês. Mas a gente está aqui para, né, para fomentar o debate, a discussão, e qualquer coisa, não se sintam me rogado em fazer alguma pergunta, e se não tiverem o domínio da língua, vocês podem perguntar em português mesmo, e a gente, se ele não entender, a gente ajuda aí, tá bom? Então, Merran, please, and welcome.
Okay, thanks a lot, Professor. Really appreciate for your kind words. I really appreciate for the time and opportunity. As you know, the part of my contribution in the field of the waste mechanics and also the compressible particle material are the one that we work together. So the main parts of my achievements is because, frankly, I have a very good colleagues and supervisor just like you. So I start to the point and start to work and present the subject that I'm supposed to talk about tonight. I'm trying to explain very, very simple the situation and the problem, and after that we are getting a little bit deeper into the problem. So just for final check, my voice and everything is okay or not?
Yes, I can hear you perfectly.
Okay, thanks a lot. Okay, tonight we are talking about the mechanical behavior of the composite with compressible particles. So we are start to the presentation. Actually, when it comes for the compressible materials, at the first step, we're supposed to talk a little bit about lightweight materials. As you know, soil itself could impose a lot of vertical stress or different type of the stress on the foundations or in the layers deep into the ground. If I gather up the range of the unit weight of the soil, sand, silts, or clay, they generally range about 1.85 to 2.3 ton per cubic meter. So as you know, when it starts to, for example, 6 or 7 meters of the depths, the level of the vertical stress is very much. Just think about the common building, that each roof or each store of a building could apply a surcharge about 1.2 or 1.3 ton per cubic meters, the square meter. So these values are comparable. So in very much time, we are trying to replace the common soil with lightweight material. But why? Why is that? And what we are looking for? If we categorize the main goal that we are seeking to reach in the case of the using the lightweight material, we could categorize them just as below. When we replace the common soil with the lightweight material, first of all, we have settlement reduction, as the value of the strain is dependent completely to stress. So when the vertical stress decreases, in somehow the vertical strain also decreases. And another thing, it is about the required time reduction in field settlements. Well, and another thing is reduction in lateral pressure. When we are reducing the level of the vertical stress, the level of the lateral pressure or horizontal stress also decreases. There is some evidence also regarding the effect of the material and type of the material on the coefficient of the lateral earth pressure. That in the next slide I will talk a little bit about it, but right now we just move on. And driving force reduction, you know, when, for example, when we are talking about the slope stability, the main part of the driving force that causes instability is the mass of the soil. So when we decrease the mass, generally the driving force also decreases. And another thing that is very, very interesting to use and gets lots of the attention of the engineer and professional is decreasing the inertial force to in the case of the seismic event. So if, for example, we are backfilling a wall with lightweight material, the level of the inertial force also decreases. Okay, according to FHWA, there is a section regarding the lightweight materials that there are some design consideration. For example, first of all, we should know in the case of the lightweight fill materials, there are lots of the potential use and application in highway engineering. But the design consideration are, first of all, load reduction. When we replace the soft soil, for example, in such cases, in the highway engineering, we supposed to make fill or embankment to make the road. And in such cases, we sometimes we are facing the foundation from the type of the foundation of soft soil. So First of all, as the embankment itself could apply a considerable amount of the load. When we replace it with lightweight materials, definitely we have load reduction. And another thing, the shear stress. The shear stress of such material, and I mean the lightweight material, is generally good, mainly in material which is characterized by their compressive resistance. For example, when sometimes we are using the block of the EPS or the block of the light concrete, which their unit weight is really small, and they have compressive resistance in the formation of the cohesion for in the point of view of us geotechnical engineer. And the third is the compressibility. Actually the compressibility is the main issue that we are talking about in this presentation. The lateral pressure, drainage characteristics, construction in adverse weather, and seismic consideration are other the design consideration which we should take care and address the issue related of. Okay. In the case of the density and specific gravity for the various lightweight materials, these are the type of the lightweight material that we are that is common in the industry: the geofoam and cellular, with the range of the specific gravity about 0.101 to 0.05. And the cellular concrete or lightweight concrete, which is 0.4 to 1.3. Actually, this type of the lightweight material could be characterized with their compressive resistance. They are not granulated, but there are other type of the lightweight material like wood fiber, tire shreds, or TDA, tire drive aggregate, expanded shale, or LICA, fly ash, boiler slag, expanded air-cooled slag, which right now is very common. These type of the geomaterial are granulated, and because of this reason, we could characterize their mechanical behavior in the form of the shearing resistance, which could be in the form of the frictional, or a part of them could also have some cohesive resistance. Right now, there are some tendency using the granulated material like EPS, as you could see, and also TDA. Actually, they are granulated tires, which when we have lots of the tire. Actually, this type of the research started from the mid-70s in the USA, as they have lots of the used tire and they want to get rid of this tire. So they started to find some way that use this material as a waste material. So different type of the product from the waste, from the tire, they start to use. They start to use this tire as a reinforcement material, but in the form of the granulated, they could decrease the unit weight of the mixture, which could be used as a lightweight material. So here we have the range of the EPS composite soil and TDA composite soil that you could see. It ranged from 5 to, for example, 18 kilonewton per cubic meter in the case of the EPS composite soil, and in the case of the TDA is between the 6 and also around 18. When you compare them with the general soil that it's ranging their unit weight from the 14 to 20, you could see that using this type of mixture, we could reduce actually the considerably the unit weights, and as such the level of the vertical stress that could be imposed on the foundation. Okay. Before I get into the mechanical response or mechanical behavior of the mixture of sand and compressible material, I think it's better that a little bit we get into the feature of the soft rigid particle mixture. Actually, it is really the new research in using the DEM, discrete element modeling, represented by Zhang et al. That I found it very interesting. So I used some of its graph and figures to give you a little some illustration. Here, you could see the mixture of the soft particle and rigid particle. At the horizontal axis, you could see the size ratio. Actually, the size ratio is D15, the size of the D15 for rigid particles or soft particles. Actually, these are the ratio of the D15 of the soft particle to rigid particle, and the vertical axis is the volumetric content. Volumetric content, which means the percentage of the soft particle. Here we have the variation of the void ratio against the D50 of the soft particle divided by D50 of the rigid particles. As you could see, when the value of this size ratio is less than 1, you could see that with increasing the value of the soft content, even before applying any pressure, the void ratio is very small. But when the size ratio is increased, so we have also increased the value of the void ratio, which means that the permeability of the mixture also increases. Here we have some graph that shows the probability of the contact point more than 4 points, which varies with size ratio, and also the probability of occurring strong contact. Strong contact means actually the grain are in the stable position, not suspended. And at the end, you could see the ratio of the number of contact divided by total particles. So if you see in the graph, by increasing the soft content, both of this value are increasing. But these are all just some graphs. Let's see what they really are. Okay, just assume we have two different ultimate or boundary condition. The first, just assume that all the soft particle could be surrounded with rigid particle, and in other hand, a rigid particle could be surrounded with soft particles. So before the stable condition, we could face two different unstable conditions. The first one is floating. Just when we mixing the ingredient, in such case, the number of contacts could not be more than 4 or 5. But when we start to, for example, shaking the mixture, the number of contact increases. But the type of the contact could not be called a strong contact that in the second graph we talked about. So when we apply the confining stress, or even when the thickness of the layer is that much, the overburden in the stress starts to make really strong content. And because if this is the reason in the case of the compressible material, you could see that the material have lots of the deformation, and actually the contact points are not in the form of the points. They are rather planar. So here's the deal. We have two boundary conditions in the form of the rigid and soft particles. And here we could see by increasing the confining stress, the void ratio of the mixture decreases. When the void ratio of the mixture decreases, it means that the hydraulic conductivity or the permeability also decreases. So the things that we should talk about and be sure about is being sure of drainage is out of question. It means that the probability of undrained condition during the loading is really high. So here we are, let's talk a little bit regarding the effective stress principle represented by Professor Terzaghi in 1936. Actually, as you know, when we talk about the total stress is the weight of all the layer above a plane. So when we have some kind of the pore water pressure or even pressure, the hydrostatic pressure could be measured or calculated. And the difference between the total stress and this type of hydrostatic pressure could represent the effective stress. And actually, this effective stress is the key point and the main parameter that we are working in the soil mechanic and geotechnical engineering. But just note that in the main equation represented by Terzaghi, sigma equals sigma prime plus pore water pressure, we assume that the contact points of the particle are in the form of the points, not in the, it is in the form of the plane. So if you have the equilibrium equation, you could see in actually the equation represented by Terzaghi is sigma equals sigma prime plus UW times to 1 minus RS, which RS is the area of the contact point divided by total area. So if in the case that this ratio is equal to 0, we could use the common equation of the Professor Terzaghi. So question, what if and just if this ratio RS is much bigger than 0? What is happening? How and where it might be happen in geometric materials? Even it's possible? Okay. We just talk about in the case of using some compressible material, mixing some rigid and soft material, mixing together, we have definitely some type of the deformation, and in such cases, the contact points are not in the form of point. So the value of RS is more than 0. So, you know what should be considered? Actually, Skempton 1961 has the answer. They assume that the contact point is not the point and represented two concepts for the compressibility of the material as a whole and compressibility of the particles, which you could see. The C, which means the coefficient regarding the compressibility of total compressibility of material, is actually the volumetric strain, total volumetric strain divided by delta P prime which is in the form of the effective stress, mean effective stress. And for the compressibility of the particles, actually delta Vp is the total volume of the particles, and delta Vp also is the volume change of the particle, not whole the sample, divided by delta UW, which is excess pore water pressure. So here, let's talk about something named as angle of intrinsic friction for solid materials. Just think, for example, we have a sample of rock. It's completely continuous, and we could characterize its mechanical behavior using the compressive resistance. But just think, what is happening if the level of the confining pressure increases? When we increase the confining pressure, the shear strength of the rock also increases. So in such case, we could call this value of the angle of intrinsic friction could be represented by the material and the quality and the type of the material. But in the case of these are happen for solids in the form of the rock or concrete, something like that. But when we are facing to granular materials, in the case of the cohesive porous materials, we have a value of the cohesion and a graph with an internal friction angle, which it approach to psi value. But in the case of the cohesionless porous material, the value of the cohesion is 0, and the characteristics of this curve, which is more Coulomb, but not in the form of the linear situation. It could be characterized by phi prime and the psi. And in the lower graph, you could see the A value, the ratio of the contact point to the whole area. In the case of the solids, it is about 1. And in the case of the cohesionless porous materials or cohesive porous materials, it's not 1, but it could approach to 1, and it is very small. So in the case of the cohesionless porous material with non-compressible particles, we could use the equation represented by Terzari in the form of the sigma equals sigma prime plus U, or pore water excess pressure. So Skempton 1961 represented the volume change and also the shear strength of the material with the compressible ingredients using these two equations, which in the first one, we have the compressibility of the particles and total compressibility of sample. And in the second one, we have the intrinsic angle friction and internal friction angle. So let's get started some clarification and illustration. That's all the theories that we talked about, how it could help us to interpret the result of the test. Okay, here we have the result of the undrained test. Undrained test on the granular material, loose sand, slag plus bentonite. Okay, if you see in this graph, the right hand is the result of the excess pore water pressure. When we start to load the pore water, start to load the sample in the triaxial situation, with increasing the axial strain, the value of the pore water pressure also increases. Okay, here, for example, in the case of the CS 100, this graph, which means the loose sand without any type of the cohesive material inside, the value of the pore water pressure approaches to 100. And the very interesting thing is that the confining pressure also is 100. So confining pressure is 100, pore water pressure also is 100. So the sigma prime will be 0. It means that there is no resistance among the particle in such case. And we should see here, we could see here, in the form of the deviatoric strength against axial strength, that for very, very loose material with a relative density of 11.45, we have a completely 100% drop in the shear strength. So what that means? It means that when the value of the RU, which is the ratio of the pore water pressure to the confining pressure approaching to 1, which is a common concept in the case of the analysis related to liquefaction. When it approaches to 1, it means we have liquefaction, static or cyclic liquefaction. Okay, so let's see here what is happening. Here there are the result of the test, triaxial test.
Ali Jun, دستت شده. علی جون بذاری یه روز به من
Excuse me.
حریف بده که سرشو حریف به چی میشه؟ بعد یه روز نقششو بازی کن چی میشه؟ بذار من شاید
آقای مهندس ربیعی.
Please activate your microphone now. Sorry, everyone, for this problem. Okay.
Okay. So everything is okay.
Yeah, just put your presentation in full screen mode, please.
It's okay.
Yeah.
Okay. So here are the results of the triaxial test on the waste, municipal solid waste, that we have done here in Uft-To with Professor Sandale Masmashado for my dissertation. Actually, in the right hand, you see the result of the excess pore water pressure for two different of the confining pressure of 15 and 300. And in the second hand, we could see the result of the deviatoric stress against the axial strain. Okay, so it is really interesting that even in the case of approaching RU to 1, we have not any drop in the deviatoric strength and shear strength, but we have a strain hardening with upward concave. Okay, so why is that happen? What is the reason? Okay, so what? Algum coisa errado? Errado sim. So here, as I told, let's spice things up a little bit more. These are the results of the test on the waste conducted by Professor Miriam F. Carvalho in the University of São Carlos in 1999. These are the result of the total stress analysis and effective stress analysis on the same material with the same specific condition. So as you could see, for example, in the case of the axial strain of the 35%, if we conduct the CD test, our internal friction angle will be 26. But if we use the result of the undrained test, measuring the total stress and pore water pressure and calculating the effective stress, and after that, if we calculate the value of the internal friction angle, we got a value around 63. which is impossible, and it doesn't make any sense. So why is that? Why the result of the undrained test and the drain test are not compatible here? What is going wrong? What is going on here? What is wrong here? Are they not follow the framework of the critical state? Actually, they do, but the problem is other things. Here, in the waste material, the contact point is not even in the point because we have lots of the compressible material here. So in such case, we could not use the equation of the Terzaghi to interpret the result of the undrained test. So in such case, here, it is the equation represented by Skempton. Sigma is equal sigma prime plus UW times 1 minus RS, which 1 minus RS, we could call it A, which is a coefficient less than 1, also to decrease the contribution value of the excess pore pressure in the effective stress. Here, for example, here we have the critical stress line, and the solid line represents the total stress in the slope of critical state value of M. But when we use the results of the undrained test, the final point, if we use the common equation of the Terzaghi, is the red point. But if we modify and amend the value of the pore water pressure using the A value, they could represent the same values of frictional angle. So these are from one of my recent paper in 2022. And here we have some experimental work. The first one is a triaxial device modified by Shariat Madari et al. In 2009. Actually, as you know, in the case of the triaxial test, when we start to do the triaxial test, the volume change of this facility or in this device actually shows the reduction or even expansion of void among particles, not deformation of the particle themselves. So we made a modification on the this triaxial device. So for the cell pressure, which we need water and the pressure to apply the confining pressure. We measure this value. What that means? It means that when the sample starts to deform, definitely to keep constant the value of the confining pressure, some value of the water should be injected into the cell. So this way, to have the constant value of the cell pressure, we are injecting the water inside the cell. So this way we could have the total volume change of the sample. And at another side, we have the volume change regarding the reduction in the void ratio of samples. So their difference could be called the deformation or volume change of the particles. And another device that we used, it was a long odometer device, which its detail could be read in one of my recent paper in 2020. We used this material also to measure the compressibility of material and compressive material. Actually, the main reason of constructing this type of the long device was the high value of the deformability of such compressible materials. So in the case of the common odometer or consolidometer, which the thickness of the sample is about 2 centimeters and the diameter is 5 centimeters, we could not use the ordinary one. So another problem of, not problem, the issue that in such odometer that we took care about is the internal friction among the material and the inside of the odometer. So we made a lot of efforts to calibrate this type of the odometer. Okay, here we have the result of the C and the CS for municipal solid waste. As you could see, with increasing the level of the confining pressure, the value of the C and CS also decreases. So here, if we could divide the CS value in each level of the confining stress to the C value of the same confining pressure, we could have the value of R, which is reduction factor for the excess proportion. Here we have the result of the C and the CS for TDA sand mixture for a relative density of 30, which is one of my also the result of my papers in 2020. Actually, in such case, in Iran we have some type of the sediments which are crushable. We call them carbonated sand. It is because there are a lot of shells and other ingredients, organic ingredients with the origin of CO3, which is completely crashable, mainly in the high level of the confining pressure. So actually we use the tire drive aggregate, the granulated rubber, to decrease the concentration of the stress to control the particle breakage. Here at the first, you could see the overall compressibility of the soil and mixed with the granulated matter or TDA, which you could see. And in the right hand, the value of the CS could be seen and observed. Okay. Here are the result of the particle breakage against the tire content or the granulated TDA. So if, as you could see, the level of the breakage decreases with the soft content, it means that the concentration or the stress in point, because the formation characteristics of this soft material could be decreased. And in this manner, we could save the shear stress and shear resistance of the mixtures. And also in the other graph, you could see the result of the cos zero. As I told you, the cos zero will be decreased with increasing the soft particles. So it is an advantage to you to add the compressible material or soft material to soil, mainly in the case of the backfill. Not only the level of the horizontal stress and the inertial stress decreases, the value of the cos zero also decrease. And here are the result of C and CS for EPS and sand mixture. You could see the trends with increasing the mean normal stress. Both C and CS decreases. We have the result of the different level of the relative density and also the value of the EPS content, which could be observed. And finally, these are the result of the A value for MSW, TDA, and EPS. As you could see, the level of the A value decreases from 1 to lower values of the, for example, 0.2 in the case of the higher confining pressure of 500 or 450 in the case of the waste or if even sand EPS, which is a lot, because with a reduction factor of the 0.2, actually the effects of pore water pressure could be neglected. So just think, if we use the same value of the UW that we could measure during the triaxial test. So in the interpretation of the result, we could not use the result directly, okay? When we are using the undrained triaxial test, or in the case of a mixture of the sand or compressible material, that we have a huge drop in the permeability and the void ratio due to the confining pressure and the compressibility of the particles. So these were all the things that I wanted to talk to you about. I tried to be clear and very simple in the explanation. So با سپاس از همراهی شما. Muito obrigado. Thanks to all of you to have such an opportunity. Okay, Professor Machado, I am free and I am I am ready to have to get the question of the guy who participated in this presentation. I am at your service.
Thank you very much, Mehan. And we have some time left, and so if you want, there is someone that want to present some question, please feel comfortable to do so. And in the case of asking in Portuguese, I think Mehan could try to understand and it would help him to answer properly. Okay? So, okay. There is any question? I think that you are completely clear, Mehan.
I am seeing some really good faces here, similar face, that familiar face, Professor Hizelda, and one of my colleagues in Iran, students in Iran. I send salute to all of them.
Mm-hmm. And I think that this subject is a very important matter in geotechnical engineering, as we are using the use of light material is increasing sharply. I think in geotechnical engineering, we are now in our laboratory make some tests using expanded clay. So it's a kind of light material, and I'm completely sure the contact points, they are not neglectable.
Yeah.
This is one thing that is absolutely necessary in engineering, not only in geotechnical engineering. If you are trying to use some different material, it's always good to try to make some innovations, but we need also to test the material in order to avoid some disasters, as we have seen in many cases in our practice, and as in the case of the municipal solid waste, for example, that we have some experience. We often face some failures, and that could be avoided if the mechanical properties of the material are properly understood. And so this is a good field and a good opportunity to the universities to work together with the companies and try to develop new techniques and new way to solve old problems. Okay.
You know, actually, I'm in agree with you. Just stick to the concept could be really helpful. Okay, you know, the main point of my presentation is that, okay, if we perform some test, it's not only the performing the test, the interpretation of the result is much more important test itself. So sometimes we have some evidence that we could not interpret at all. As you told me during the time that I was here in Brazil as a student, just be sure the experimental results could be how could I say, repeated again and again. So this way we could be sure that, okay, our results are good. So when we could not interpret the results, it's another issue. So as you all remember, regarding the stirring hardening of the material, waste material, and increasing the pore water pressure during the test, they were not relevant. Okay, so after that we start to realize, okay, when some compressible material are under the confining pressure, actually the compressible parts are going to be squeezed, and the water inside the mass of the waste migrate to the boundary or border among the flexible rubber and the sample itself. And as you remember, when we finished the test, we removed the test, and the rubber, there was a lot of water among the rubber and the material itself. So actually, when we start the water pressure, measure the water pressure, and equalizing the confining pressure and the pore water pressure, which approached to 1, it is happening, but the contribution of the pore water pressure to the level of the effective stress is another issue. Actually, I am encouraged the students who want to have a good subject for their Master of Science thesis or even doctoral thesis, following these subjects with some good program of testing could be a good breakthrough and could be a really good subject in the case of the even doctoral thesis. Are you agree?
Yes, totally. So it's now 6 to 7. So if there is no other question or other contribution to the meeting, I will finish it. Okay.
Mm-hmm.
Lucas is asking, what's the name of the soil you said concerning the crushable particles?
You know, this type of soil, let me show you here. This type of soil is, we say it the carbonated soil or calcareous soil. You know, the main part of this particle, this soil, are from ingredients that lives, or organism that lives in the sea. So let me show you here.
It's a calcareous material.
Yes, the main source of such material are CO3. Okay, let me show you some of the picture here. Okay. Okay, these are type of the how could I say, the organism that living in the seasides. For example, the shells, different type of the shells. I'm trying to find some here. Okay.
Okay. I feel that you could send him some paper you have published recently.
Okay,
Okay?
it's okay. Yes, definitely.
Tudo bem, Lucas? It's okay. Okay. So, but it's essentially a calcareous material that have some crushable particles, and then mainly when the stress level is high.
Start to crash.
Yes, and this will cause some settlements to happen. Then using lightweight material could avoid this problem. And I'm pretty sure Mehan could send to you a paper. Just left
You
your
know,
email in the chat, please.
no, in the first page of my presentation, I put my email here. So here, let me add also my Gmail. So if even in the research gate, if you go there, all of the paper that I was talk about, I will talk about, you could get the access of full paper. So if even you have not an account, you could mail me and everything is gonna be okay.
Ok, pessoal. Então, muito obrigado a todos pela presença. Tivemos uma boa audiência, uma excelente palestra, na minha opinião, é um tema interessante, né, novo. Mehan, could you share your slides?
Tranquilo, com certeza.
Okay, so please ask Mehan. Vocês podem pedir para Mehan para passar para vocês aí o material, tá bom? Muito obrigado a todos, boa noite e obrigado pela presença de vocês. Muito obrigado.
Obrigado também. آیه دکتر خیابانی شب شما بخیر قربان. آیه مهندس آقاوادی شب شما بخیر. Ciao.